Hello and welcome back to our ivy growth project. Now we're going to pick back up right where we left off, which was with our ivy growth system, our basic branching system, which gives you this nice detailed look. And we've got our main stem, our branches or shoots, sub-branches again, and then we've got our petioles coming off that last branching system. But the distribution overall is quite random, and we can randomize it even more. We can go into our emitter here. Let's change the seed to something different, and let's go back to the beginning. And you can see immediately we end up going in a totally different direction, and it biases to the left quite a lot. And if I do another one, let's just do a ×2. A bit more in the middle, but still going left. And then a bit more down distributed in the middle there. So that's interesting, but it's totally random and out of our control. And all it's doing is it's changing the, each particle has a different bend value, if you like. So each time it hits this frame range, or sorry, not the branch, the bending, each time it hits, it's going to be between these two values, and then it just continues until eventually it ends up at its full length and stops moving. But we want to have a lot more control over this. Now, in reality, a plant tends to grow based on some stimuli. And in botany, in the study of plants, it is known as a tropism. So all that means is it's something to do with reacting or turning. And it's reacting or turning based on something. So you have these different ones. The main one that everyone probably knows about is that plants tend to grow towards the light. Not all, but that's a pretty common one, and that's called phototropism. So turning towards the light. And we can create a system based on that, and it's quite simple to do. We're going to just have it basically aim at an imaginary sun. We could even put the sun in the scene as a light, but we don't need to do that. We could just have it as a null or something like that in the scene. So actually, let's do that first. So let's just add a null to the scene. So if we go to create object null, I actually have a shortcut set for that, but we won't use that. I'm going to put it over here, and then I'm going to make it. We should make it a star, of course, because it is our sun. Of course, is a star. There we go, and I have it face the camera. And let's make it yellow, just because I like to color code things in my scene. And then if I make the icon color yellow as well. There we go. And we're going to call this our sun target, I guess. There we go. Now, what I want to do is I want to bias the particles towards that sun target. Now, I could put an attractor on here. Problem with the attractor is that it's going to have different values depending on how far away it is. And also everything will go to one point. I sort of want it to be a bit more parallel. I want it to head towards the light, but not exactly to this pinpoint position, because otherwise we'd have to have it quite far away to make it grow kind of naturally. So what I'm going to do is I'm actually going to have a direction modifier. So if I go to our modifiers, need to be on the object tab, motion modifier, XP direction. This is a very useful modifier, of course, and I'm going to change it from these specific heading settings and absolute operation to use modifier rotation. Now, if I just move this up so we can see it a little bit here, I press play now. It's not going to do too much, but it's going to push them along the Z-axis. If I rotate to the side 90 degrees, it's going to bias all the way over to the right-hand side there. Now, I think you can probably see where we're going to go with this, and it's super simple. And that is we're going to have it target this object over here. So I'm going to put it back down at 0. So just 0 that out. And if the acuteness of turn currently is 15%, we might add some variation to that. I'm not entirely sure. We'll have a look at how it looks first. So we're going to add a target tag to our. It's quite a simple thing to do. Right click, Cinema 4D tags, target. And then all we have to do is drop the sun target in there. And I'm going to put the sun target next to our direction mod, just so it works like that. And now we're going to have given it a biasing direction. Excellent. So it's a bit too much at the moment. You can see it's not allowing them to sort of leave and go off on their own sort of journeys. But let's So let's reduce down the acuteness of turn a bit, or we might add some variation into it, like I said. If I just drop it down to sort of 5%, that might be too little. It is having an effect, because if you turn this off, you'll see that it biases much more to the left. But because it does that, it sits in the middle here a little bit more. So more than that, let's go for 10%. It's a bit more direct. Maybe even less, 7%. And you can see it can spread out a lot more. And also our shape here isn't particularly exciting as well, like of our wall. So once we've got different shapes and things, it's going to look a little bit more interesting. So let's move our sun over there just to test out our theory that it should go towards the sunlight. It does. And if I move it across there, the ones that are still moving will also go back that way as well. One more time. There we go. Okay, so that's one kind of tropism, and we can. There are other ways we could direct this. We could use all sorts of following splines, or using a flow field even with a spline in it. But that's a little bit overcomplicated. I think in this situation where you want an organic system, you need to let X-particles and let the particles do their own thing a little bit. Otherwise, you end up with a bit too much of an ordered look. So I actually quite like letting them roam around the surfaces and just generally go to a certain direction. One other thing, which we've actually kind of dealt with a little bit already, it's another tropism, is thigmotropism. Now that's another fancy word, a bit like phototropism. Thigmotropism means it reacts to touch. So it literally, if it makes contact with something, it's going to react in a different way. And we've already kind of done something like that in the sense that we have an avoid modifier pushing our petioles away from the surface. And also the follow surface modifier, which gets our main stem and branches to stick to the surface. So that's actually another tropism, which we already dealt with. Now we can add to this and make it react in different ways to these objects or obstacles. And let's put an obstacle in the way. So let's throw a sphere in here. I'm going to put it in the other objects section. Make it a nice icosahedron. Push it into the wall a little bit. Make it a little larger there. I might change the display mode to isopalms. I pressed NI there for that. If you ever, it might not be a default, but just go into your display in the viewport here. It just cleans up the display nicely. And what we're going to do is we're actually going to add another avoid. So actually I'm going to duplicate this one because I like the settings it has, but I'm going to change the groups and the surfaces that it's going to avoid. So I'm going to delete that one from there. I'm going to add our sphere. And what we should have done is we should follow our own advice and actually add another connect object. So add another connect object, drop it in there, and then we'll call this let's call it by its actual, I'm going to spell this wrong, definitely, but thigmotropism. You don't have to use these names, obviously. This is just, I like to do this because making things a natural system similar to real life obviously helps sell that effect. It's not always practical, so I will say that. But in this case, I think that's perfectly fine to call it thigmotropism. Let's grab our avoid, and instead of the sphere, we're going to put our connect. That just means we can add more objects later on. Okay, so detection distance. I'm actually going to make this a bit higher. I think we'll go for a good meter around that surface. And the groups affected, I actually want all groups to be affected by this. So I'm going to actually kill that, delete or remove that petiole specific group out and press play, and let's see how this reacts. And you'll see it actually goes around. Even though it's going towards the sun, it actually goes around so it knows that this sphere here is actually something to avoid, and it will go around. Now I can shrink that down and put that over there like this. We could even reduce that avoid distance down a touch. Keep the variation up. And you'll see, hopefully it'll avoid them, and you can see it goes through the middle of them there. but it's still moving in that general direction towards the sun. Again, one more time. You could even animate these and it would probably confuse them, but yeah, let's put that one there as well. Just change the display so we can see surfaces. And there we go. We can actually have them avoid these obstacles. Another one would be to actually have them stick to stuff, but the problem there is it'd have to jump from different objects. It is possible. For our system, for our purposes, I'm gonna stick with our two kind of different types of avoidance system. One cool thing we could do here is actually throw some type into this avoidance system. So let's go to our MoGraph, motion text, or MoText. I don't think it's motion text, is it? Maybe. Throw that in there. Let's call this avoid. What I'm going to do is I'm actually going to add in more source points here. So let's have it move upwards. So make sure our direction is up. And let's go to our emitter and let's add a few more source points and spread them out. And let's just play that back. And you can see it's going to avoid the letters. Nice. Now I think our particles are actually moving a bit too quickly for a growth system that we want. So I might actually slow things down a bit. And we can do that in a few ways. We can actually have it just in the groups. So I might just drop these down. I'm not going to drop these down too much, but I do want to give them a bit of variation. So I'm going to leave their maximum is going to be 150, but their minimum is going to be lower. So it's going to be around about 100. So there's a few of those. The radius is fine. We could definitely give the second set of, or maybe if I give this first main stem a larger variation, it might give us a nice, yeah. So you see how they move at different speeds, and I believe those petioles are inheriting a way too quick a speed. So let me just double check where they're getting their speed from. Yeah, so we're using the emitter speed there. So what we could do is we could have them each inherit. So we could have them inherited, or we could set the speed. So one way to do it is to set that speed. So if I, get off the branching. If I set the speed, and there we're back in control of those. But they're all even at the moment, so we'll probably come to give them some variation with an actual speed modifier. I seem to have displayed the particles. There we go. Just hide our emitter and it won't display them. But we can see our tropism's working nicely. Getting quite a dense amount of ivy now. We could also put that avoid just to show you how dynamic it is. We could throw the avoid. Now it's changed the Phong shading because I should change that to manual. Let's put wireframe on. Now they should climb over those. Oh, it starts to, but then I think what's happening is that it goes through some of them because they're not connected. That's cool. Because this isn't one contiguous volume, which is actually something we're going to have to deal with a bit later on in our more complex scene. Because they're not connected, they can actually go through the sides of these objects. So we need to do some kind of meshing operation or something like that to get them to flow over the surface. But in general, it's working nicely, and it's climbing all over our letters and our surface like that. And it's all going in the direction we want it to. So if I move this over to the left, phototropism, remember, towards the sun, and off it goes. Now we're probably not getting full real-time playback there. There are a few things we can do to optimize things to make them faster, and this is just general workflow stuff. But in your trail objects, we don't actually need the color to be stored in the trail object. Now it's stored in the trail object because sometimes you want to take the color of the trail or color of the particles and pass it into the render, into cycles 4D, and have it actually show in the render. We don't need to store that data. We also don't need to store the thickness data because I'm going to take individual control of each of these segments, basically. So what I'm going to do is I'm going to select all of our trail objects, go to the thickness and color tab, and make sure I check this no thickness or color data. And this will just speed things up, means it's not having to store all that extra data, means the cache will be smaller as well. And there we go. Now we're still not going to get real-time playback, so always cache to get that real-time playback feel. I'm definitely going to have to work on the petiole speed and probably the petiole density. They look quite dense at the moment. Even though I like the look in general, we won't really know until we start putting leaves on there. That'll be up next. Just before we go though, let's have a quick look at the scene and have a look at one last thing, which is how the particles are going to be emitted in our scene. Now currently we've got this defined emitter where it's just 5 separate emitters and they're kind of specifically placed, and then obviously they're grid based or in line. We're going to want a bit more control over the exact positioning of where these are going to spawn. So what we could do is we could duplicate this entire system several times and move the emitter into place. But I prefer a bit more of a dynamic way, a bit more of a procedural way, and that's using geometry to emit from. Now we're not going to use the source geometry because in some scenes that geometry might be super dense and you want to keep it as efficient as possible. So I'm just going to use small polygons and I'm going to make them nice and small like that. I'm going to drop them into our other objects section. I'm going to add another connect object. And I'm going to drop that into the connect object. And we're going to call it Emission Geometry. Okay. Now go back up to our emitter. Let's just display it so we can see the defined emission sources will change. We're going to change it to object mode. Then we're going to go and grab our Emission Geometry Connect. We're going to change it from, well, it's already polygon center, so that's perfect. And then we're going to say 1 particle per source element, which just means that at any one time it's only going to emit, or any one frame, it's only going to emit 1 from each of the source points. And we're going to change it to a shot mode. So obviously if we wanted to stagger it, we could go for a rate mode or a pulse or something like that. But with this, I'm just going to pull it away from the wall a second and press play, and you'll see we get 1 emitter out of that. Now, if I start duplicating these, note that's not going to reach the wall because the follow surface doesn't have a far enough attraction. So let's move that in. Oops. Nice and close. And in our actual scene, we might want to use snapping or something to get it close to where we want to in the scene. But I really like this way of doing things because obviously it also has a normal direction, so you could angle these in different ways. And we're actually going to bury them though, so we're going to plant them into the. We can think of these as our seeds. So seed 01, seed 02, and let's make another one. So seed 03. Let's put this guy up over here just to demonstrate. Let's put our motex back into our avoid. And there you go. So it's just a bit more control over exactly where they're going to spawn. Oh, so the cool thing is you can see they do spawn like a distance away from the surface, but because of their tropism, they're mostly ending up back on the wall. But if you can see here, this one's unleashed, and it shouldn't really be that far away from the thing. So we need to bring it a little bit closer at the beginning. Make sure everything gets trapped. Move it in nice and close. And up it goes. Excellent. So I'm starting to feel like this is a pretty dynamic system. It's working quite well. Well, this one as well. Getting too many escapees here. Bring that in there. So as you can see, our system, we have loads of control. We can change the direction, use our sun target. Our phototropism going on there, nicely done. And next up, we're going to actually have a look at the petioles in more detail and also the leaves that will sit on them and how we're going to generate those. And whether or not we're going to have them unfurling animated or just scaling up. There's different ways to go about it, and we'll explore that in the next scene. So I'll see you in the next video.